Reinforcement learning is not one of the easy topics to learn, explain and understand. But in this video, I am going to explain you reinforcement learning like you are 10 years old. Let's try to understand all details of it in this video. First of all, what and why of reinforcement learning? Then we will see Q learning basics. I will tell you what is Q learning. Then we will understand key concepts of reinforcement learning. We will understand the most critical part of the video known as Q table. Okay. I will explain you what is Q table, how it is updated. And then we are going to do a end-to-end Python demo. All these things together will give you a very solid understanding of what is reinforcement learning, how it works, and why it is so complex to understand. But don't worry, in this video, I will make it very simple for you to understand. I will break it into piece by piece. So, what is reinforcement learning and why we are learning this? Why at this time it becomes really important? This is the time of LLM, high-end models, chatbots, and different kinds of AI agents, right? So, why reinforcement learning we are learning? If you go to Twitter or if you go to Google and search for, I just searched here, robots navigating path, or you can also search for robots playing chess or autonomous cars or things like that, right? Any situation where you see that AI is taking a decision based on the environment. Just to show you one video here. For example, if you see this video, right? This system is taking the decision of where to move based on the environment. This kind of scenario is very, very normal nowadays, and this kind of area of AI is booming nowadays. And the reason for that is the AI system need to take decision based on environment. In this case, as you can see, and you can see some more videos here where AI systems are navigating through the paths and taking the right decision where to move, where to go. Okay. So these are certain use cases where these are applicable, but these will be very much useful when you talk of AI assistants, AI agents, or things like that. Hence, you have to really understand what is the concept of agent and environment based learning. So, I give you some background of why it is important to learn, because this, together with high end model, will make the foundation of upcoming revolution in the AI, to keep it short. So you have to understand what is reinforcement learning and why we are learning this. To keep it very simple, reinforcement learning is a different kind of learning. What is meant by different kind of learning? Let's try to break it down further. First of all, whenever you have heard of machine learning, since the time you are starting learning machine learning, right? So normally, machine learning you will be hearing or you will be noticing supervised machine learning, unsupervised machine learning, and there are semi supervised and different varieties in combination of these and things like that, but let's not go into those details. Supervised and unsupervised. What is the meaning of supervised learning in normal plain English? If somebody asks you, whenever supervised learning happens, we are trying to either predict, okay, or estimate. So if it's a regression scenario, we try to estimate something. If it's a classification scenario, we try to predict something. But in all these scenarios, right, we have labels in the data. What is the meaning of labels? Most of you are aware, labels means the target variable which you are trying to predict or estimate. This is your supervised learning. What happens in unsupervised learning? Unsupervised learning is all about finding patterns. Okay, so I will write here find patterns in the data. Some examples could be k-means clustering or association analysis or things like that, where there is nothing to predict or estimate, but we are trying to find patterns in the data. This is your unsupervised machine learning. There could be semi-supervised mix of both and things like that. But what we are learning in this video is a very new kind of learning, a very new approach of machine learning known as reinforcement learning. I will write here RL. What is reinforcement learning if somebody asks you? A very, very simple and core definition of reinforcement learning will be, in reinforcement learning, The learning happens through agent. Okay, I will explain you in a moment what is agent, and environment interaction. Okay, agent and environment interaction. When the agent and environment interaction happens, then there is a feedback mechanism through which the learning happens. What is the feedback mechanism here? I will explain you in a moment. But remember this, what is reinforcement learning? A different way of learning in the world of AI or machine learning, where the learning happens through agent and environment interaction and a feedback mechanism. This is very high level. I am going to go into more deep now. Fine. Anywhere if you have a question, please point that part of the video in the comment and ask me question. Don't hesitate to ask. None of the question is a bad question. Everything is a good question. Okay. So agent, environment, and feedback mechanism. Now, this is a very complicated topic. So I have kept my note with me so that I don't miss anything important here. Now, few things you need to understand here is, in reinforcement learning, there are various ways in which you can train a reinforcement learning system. There are various algorithms. Okay. So for example, in classification, you can use different algorithms. In regression, you can use different algorithms. In reinforcement learning, you can use different algorithm or way to learn. What we are going to focus in this lecture completely is the most famous and most known learning in the world of reinforcement learning, known as Q learning. So what is Q learning, how it works, and how it implements reinforcement learning? This we will see in rest of the video through theory and Python example both. First of all, what is Q learning and how it works? To understand that, you have to first of all understand I wrote two words there. One I wrote agent, other I wrote environment. Now, if you see the video I showed you in Twitter now, what is happening is a robot is trying to navigate through path. So robot becomes the agent in this case. And in whatever setup the robot is moving, right? That setup is the environment. Very simple. Agent is something which moves. Environment is something, the setup or the structure or the environment in which the agent has to make a decision and move. Here, what I'm going to do is I'm going to create an environment. So let's think like this. This is a 5 cross 5 grid. Okay. So I'm trying to make a 5 cross 5 grid. 1, 2, 3, and 4. Okay. And here also I will say 1, 2, 3, and 4. So this is a 5 cross 5 grid. So I have two axes here, x axis and y axis, right? Imagine that there is a robot which is currently standing at this position. So what is the position of the robot currently? 2, 2. Just an example I am giving. The current position of the robot is 2, 2. And the destination position of the robot, I am writing in red here, the final position or the target position of the robot is 4, 4. Okay. This is the target position. If the robot reaches 4, 4, then that's the job done. That's the definition of done. Fine. From 2, 2, in how many directions robot can move? This is first direction. This is second direction. This is third direction. And this is fourth direction. Right? How many directions robot can move from 2 to? Up, right, down, right, left, and right. There are four options to move. Fine. In which direction robot should move? How it will learn? It will learn based on the feedback mechanism if it is moving in right direction or not in the right direction. How do we do that? How do we set that in the system? Let's try to understand few key terminologies and then I will explain you why it is important to give rewards and feedback mechanism. So the first thing that you need to understand in the context of Q learning or reinforcement learning is agent. Please pay attention here. These are the backbone of reinforcement learning. So what is agent? Agent is the entity that moves, or the robot or the AI system. Okay? The entity that moves or that makes a decision. Fine? That is the agent. What is the environment? Environment is this grid in this situation, and in the video that I showed you on Twitter, right? That room is the environment. Okay? So I will say here the environment for the agent. Very simple. The environment for the agent. Next thing that you need to understand here is state. Okay? And the meaning of state is current position of agent. Current position of agent. So what is current position of agent? I just told few minutes back. State is normally represented as S. Current position of the agent in our case is 2, 2. So what will be the state in our case now? 2, 2. Okay. So state in this situation is 2, 2. Fine. The next thing that you need to understand here is action. So I just explained you there are 4 actions that the robot can take from here: up, down, left, right. So action is nothing but possible moves, to keep it very simple. Possible moves. And here, what are the possible moves? As I told you, up, down. I'm writing it knowingly because we need to code this as well. Up, down, left, and right. And you have to set a feedback mechanism when the robot moves from left to right and right to left, or whatever it is. If you understood what is action and what is a state, then you need to understand a very important concept here known as Q table. Okay? Q table is basically a metric of, or a table of, row and column arrangement of state action pair. Remember, state action pair. What I mean by state action pair. So in our current setup, how many different states are possible in our current setup? How many different states are possible? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 cross 5, right? Those many different states are possible. For example, 0, 0 is one state, 0, 1 is one state, 0, 2 is one state, 0, 3 is one state, 0, 4 is one state. And similarly, 1, 0 is one state, 1, 1 is one state, and so on and so forth. So 25 different states are possible. Here, just to demonstrate you, if we have a simple table, for example, if we have, let's say, 4 states only. Okay, so imagine this is a simple table: 0, 1, 0, 1. In this kind of environment, how many states are possible? 4 states: 0, 1, 1, 0, 1, 1, and 0, 0. Correct? So in this type of small setup, just to make you understand what is a Q table, on row you will have state. Okay, and on column you will have action. For example, state 1, 0, state 0, 1, state 1, 1, state 0, 0. And in action, you will have 4 possible options, right? Up, down, left, and right. Okay. And then here will be some values. I am not going into details of how these values will come, but I will explain you. Let's put a 0 for all these values now. And please remember, the table that you see in front of you is the most important concept of Q learning or reinforcement learning in this situation. What is a Q table? A Q table is basically a metric or a tabular arrangement of state and action, and there are Q values against all these. Whatever 0, 0 you see, these are nothing but Q values. Okay? 0, 0 is Q values. Remember, Q values. So this concept is called as a Q table. How the values will be updated, I will explain you in a moment. Before that, let's try to understand some more concepts, some more key terminologies that you should know before we dive deeper into and implement in Python. Okay, so you have understood what is agent, you have understood what is environment, you have understood what is state and what is action. Now, few more things you need to understand here. One is called reward. Okay, so here I will write reward. What is the meaning of reward? The meaning of reward is when the agent takes any action, right? What is the feedback that you want to give to the agent? When the agent takes any action, right? What is the feedback? For example, if the agent goes up, what is the feedback? If the agent goes down, what is the feedback? Left, what is the feedback? Right, what is the feedback, right? So, feedback for the action. Very simple. This we have to code also. Hence, if you understand this, it will be easy to code. 6, you have to understand learning rate. Now, most of you would be aware of the concept of learning rate. Learning rate is basically how fast or how slow you want to converge or you want to move to the next step and things like that. In this scenario, learning rate meaning this determines learning rate determines how much new value, right? New value. I'm talking about updating the Q table, okay? New value overwrites overwrites old value or new information overrides old information. That is your learning rate. I will explain you how this will work now. Okay, just before, one last concept is known as discount factor. Discount factor. The meaning of discount factor is basically suppose the agent takes a action. So the agent will move from one position to another position. For example, in this scenario, let's say 2 is current position and future position is, just for example, I am saying 2 3. Just imagine 2 3 is the future position. So 2 is the current position, 2 3 is the future position. What discount factor tells you is at future position, what is the importance of reward? So here I'll say importance of reward in a future position. Importance of reward. We will do calculation now, don't worry. In future position. Future position. That is importance of reward in future position. And learning rate is represented by alpha and this is represented by gamma. And from all this together, right, the formula of updating of Q value comes into picture. So if you remember, I just told you Q value is basically this table. I mean, this is Q table and these values are Q values. How do you update the Q value and what is the importance of these Q values? First of all, how do you update the Q values? Initially, when the system starts learning, it doesn't know anything. So all these Q values can be taken as 0 for simplicity or for understanding, right? And it makes sense also. Initially, there is no information in the Q table, so 0 value. How the value will be updated? I will just write a formula here which will look complicated, but it is not. So basically, Q value is nothing but the value at one position and a action. So basically one state and the action. So I am denoting Q value at one state and one action like Q of SA. To keep it simple, you can think of Q at 1 1 left. Okay, this is very simple to understand. At one state and action combination, what is the Q value? So if you have to update this, which we have initialized with 0 just to keep it simple, the formula here is QSA, that means the previous value, plus learning rate times, learning rate basically we can tune, reward, okay, so reward plus reward that we will provide for this particular action, gamma times, okay, gamma times max of future reward. So I will write here, if that action is taken, then what is the maximum future reward that can be got, that can be obtained, and minus the QSA again. So What is the meaning of this formula is, to update the Q value, you take the existing Q value and do some modification in that. How you do modification in that is by using learning rate, by using current reward, by using discount factor, and by using future reward. Let's try to understand with a simple example how this will be done. And for that, I'm going to take a use case here. So the use case is very simple. I will write it here. Please update. If you understand this part, it will be very easy for you to understand Q table. Please update Q table. Okay. Q table. If agent is at, if agent is at 1 1, okay, agent's position is 1 1, and moving right reward is +1. So what is the reward for moving right? +1. So reward is something that we set in our program. Moving right reward is +1. Okay. Now what we have to do? We have to update the value. So what we have to update? We have to update Q1 1 and right. Okay. So this value needs to be updated. Imagine that metric where 1 1 and right, that cell value need to be updated. If you see the previous Q table, right, 1 1 right, this value needs to be updated. Imagine like this. To update this value, for simplicity, let us put a previous value here. So in place of 0, let us assume that, just that my calculation should not be all 0. I am just assuming 0.2 is the current value here. Okay. And I will update now. Current value I am assuming 0.2. So I will go here and I will simply plug in values. Q11 right is equal to, what is the current value? QSA. What is my state and action current value? That is 0.2 that I just put now. 0.2 plus, what is my learning rate? Learning rate is something that you and me decide. Let's put 0.1. What is my reward? So in this you can see reward is +1. So we will put +1. What is my discount factor? Discount factor also we can decide. So we will put 0.9. Just a decision. That's our decision basically. So how much weight you want to give to the future reward. And what is this thing here? This thing here, okay? This thing here tells you that if the agent moves right, okay? If the agent moves right, then what is the maximum reward that agent can get in the future position? And how do you get that? You get that by when the system learns, right? The system will present reward for all the positions. So when I say reward, it is basically Q values, okay? Q values for all the positions. So in my current position 1 1, right? The if my 1 1 moves to right, if my agent moves to right, then where it will move? So come to this here, okay? My agent is currently here, okay? My agent is currently here. If my agent moves right, where my agent will move? My agent will move here. So what is the next position of my agent? The next position of my agent is 1 2. That is my future position. Okay. Q table for 1 2, for 1 2 position, what is the maximum reward that it can get? So 1 2 will have its own entry, right? So in this Q table I don't have a 1 2 entry, but in this bigger scenario, right, 1 2 will have its own entry, right? So in 1 2 position, what is the maximum that it can get in that row? Okay, what is the maximum that it can get in that row? For example, if I ask you for 1 2, imagine the entry is 0.1, 0.2, 0.4 and 0.5. Okay, what is the maximum in all these? So 0.5, that 0.5. So 1 2 is the future position and 0.5 is the maximum future reward. In this case, the future. So that 0.5 will come and sit here. Okay, and then it will get the 0.2, the previous one will get subtracted. So if you see different parts, right, here I am considering previous one, Here I'm considering the learning rate, how much I want to consider the, how much I want to change. And here I'm giving weight to the future value. If you compute all these things together, right, 0.2 plus 0.1, 1 plus 0.45 minus 0.2, 0.2 plus 0.1, 1 plus 0.25. Okay, so 0.2 plus 1.25 and 0.1, so maybe 0.125, 0.125, and this is 0.325. So the Q value will be updated in this scenario to this value. So 0.2 will get updated to 0.325. This is how your Q value will get updated in your Q table. So this is how the learning happens, or this is how the training happens. Your Q value will keep updating after every iteration using this formula, and this is basically your Q table update. Now, if I have to write this in Python, I need to define certain things here. What I need to define, let's try to understand. One thing that I need to define is basically, if I have to code this in Python, right, I will have to define my agent and define my environment. Okay. After that, I will have to define action and rewards. Correct? Define action and rewards. Then I have to define move or select move. Define or select move. In selecting move, there is something that I will explain you now, but other part of code will have learning. So by learning, I mean to say updating Q table, and then showcasing or demoing, where we will be using the above learned Q table and we will be making the robot move, making the agent move. Okay. So define agent and environment, I will write in Python now. Action and rewards, I will write now. In the selecting move, right, there are two things we can do. One is called explore, okay, and another is called exploit. Basically, what we are trying to say here is, when the learning is happening, right, then we want system to explore by moving up, down, left, right, and keep updating the learning in the Q table. So basically, we are not giving a Q table to use. We are saying build the Q table from scratch. That is your exploration. So you are telling the system, learn multiple things, move in whatever direction you want, and learn the things. That is explore part. Okay. And what happens in exploit part is basically, once your Q table is ready, then this is your Q table. Based on this, go ahead and take the decision. That is your exploit part. So what happens is, when we start learning, right, suppose we want to run 500 epochs from 0 to 500. In the initial epochs, or in the initial, here we call it episodes. Okay, episodes means iterations. In the initial iterations, what we do is, we are in explore mode. Okay. And as we move to, let's say, more episodes or more iterations, right, we slowly move from explore to exploit, so that the learning that happens also goes and update the Q table, and Q table also gets enriched. This happens in the training, but when we are predicting, or when we are using, or when we are not learning, then we are always in exploit mode. But in learning, we will first explore and then slowly move towards exploit. And how we control this is by using a parameter. I will show you in Python now. Okay. So that is called exploration parameter, or there is a different name. I will just show you now. And then the learning and the showcasing. So just to recap before we go to Python, what we will be doing, we will be defining a agent, we will be defining a environment, we will be defining a reward mechanism, and then we will update the Q table. And then first we will explore, then exploit, and then we will do the final demo. Okay. So let's go to my Google Colab here. reconnect. So if you see this code, right, the first piece of code, agent, I told you define agent and environment. Okay, I'm writing a class here, grid agent. And what this part is doing is, if you see here, grid size is equal to 5. So I'm defining the same metric that you saw in the theory, 5 cross 5 metric. And this is self dot value table. Value table is nothing but your Q table. I'm calling that action value table. I told you about exploration and exploitation. Here, exploration probability is 1, which means I'm completely in the beginning in exploration mode. Okay. And I have to define a target for my system. Target means where I want to reach. What is my final position? Where I want to reach, right? If if I say to the system that 4 4 is my final position. Okay, so I have to tell a initial position and I have to tell a final position. So my initial position is this 0 0. Okay, this is my initial position and this is my target position. Okay, so I'm telling to system my target position is 4 4. Okay, that's what this piece of code is doing. So defining agent and environment. The second piece of code, what it is doing is, it is simply initializing the position, initialize the agent. If you see here, I'm simply saying initialize the agent at 0 0. Okay, so just you go and start off the grid, you put the agent 0 0. Fine. Then here I'm taking the action. So I told you we have to define a different function or different part for action. Here I'm saying take action, self move, update position based on chosen move. So this function can be called with the move means up down parameter, up down left right, and it will simply see if move is equal to 0 then move up, if move is equal to 1 then move down, if move is equal to 2 move left, if move is equal to 3 move right. So it is basically, it will move your position of agent to left right up and down based on when you call this function what you give in move. Don't worry about this max of this. This is simply to ensure that it doesn't move out of the grid. Okay. So for example, here, if I am at 0 0 and I say move up, that doesn't make sense, right? I have to limit it. If I'm at 0 1 and I say move up, that doesn't make sense, right? So that min max is just to control that. Don't worry about that. It is simply, if you give a move, if you say up down, it will simply move up and down. It will change the position of the agent. Okay. And it will give a reward as well. So reward I'm defining here. Reward is 1 if position is target. If the position is target, then reward is 1, otherwise -1. So target is what? 4 4. Is done is equal to self dot position double equal to self dot target. So when this function runs, right, what it will give you is, it will give you the new position of the agent, it will give you the reward, and it will give you if it is the final position or not the final position. Okay, these three things this take action will do. Fine. So we have defined environment, we have defined agent, we have defined action. How do you call that action? Okay, so that we will do in learn. But before that, select move is another function. Select a move based on exploration or exploitation. That is what I was explaining you now. np.random.rand less than self.explore.prob. If you see explore.prob is here. Initially it is 1. Okay. But as we move into more iterations, what we will do is we will keep decreasing this. How we will keep decreasing this is, if you see in learning, right, for every time the learning happens, I am multiplying with 0.99, which means reduce exploration probability gradually. So initially I'm starting exploration probability at 1. In my learning, I'm decreasing it by 1% every time. So slowly what will happen is the value will start coming down. When the value will start coming down, then this if will not get satisfied. Okay, and it will go to the else. Else means it will not go into the if. So if you see here, np.random.rand, there is a very high possibility that this number is less than 1. So it will simply go and it will explore randomly. np.random.rand int 4 will give you either 1 2 3 4 anything. Okay, 1 2 3 4 anything means when you call this function, right, select move output, here you are calling move, it can be 1 2 3 4 anything. And when this function sees, sorry, 0 1 2 3, when this function sees 0 1 2 3, right, anything can be the move. This is in exploration mode. Okay, when in the beginning, but slowly when the exploration probability uh, parameter comes down, right, what will happen is it will go to this mode here, and it will go to, if you see here, value table is nothing but q table. It will go to the position and it will see the highest value. So what it is doing, see here, it will go to the q table. This is the q table. If you see this line, right, np.argmax value table, go to the self dot position, it will go there and take the maximum value. Okay, so for example, if it is at 1 1, maximum value is at, let's say, left, so it will simply pass left. Okay, if maximum value is at down, it will simply pass down. So initially it is exploding, later it is exploiting. And then comes the final learn function. Here I am running 500 times. It is very simple. For 500 times, what it will happen, first of all, it will go to move, self.select move. So move function, first of all, initially it will be in explode mode, later it will be in exploit mode. So it will give 0 1 2 3 integer, whatever it is. Once that integer comes, right, take action function will be called with that integer. Okay, take action function will be called with that integer. What will be returned is new position, reward, and if it is completed or not completed. Once that is done, right, then we will update the q value. As I told you, update the future value, np.max self.value table next position. That is what I was trying to explain you here. If you see here, right, I was telling you from the next position, what is the maximum value that it can get. Here I was trying to explain you, right, from 1 1, if it moves to 1 2, then at 1 2, what is the maximum thing it can get in that position, right? So that is coded here. If you see here, best future value is equal to np.max value table, go to the next position. And what is the next position? It is coming from the take action table, right? Now the same formula that we learned now, self.value table current position move, this we are updating here. Now we are updating QSA. Okay, this highlighted thing is QSA is equal to 0.1 times, plus is equal to means addition in self. Okay, 0.1 into reward plus 0.9 into best future value minus self value current position move. Same thing that I'm writing here. Okay, see here, 0.1 is the learning rate, 0.9 is the discount factor, and all these things I have already explained, best future value and thing. Current position is equal to next position and reduce the explode probability. So this is learning. What is happening in learning again? First thing is your move. Where from move will come? Move will come from the decision of exploration exploitation. You get the move, you get the next position, you update the Q table, and you then decrease the exploration probability again. Okay. This is your entire learning process. Once the learning happens, you will have a Q table. Okay. And once you have a Q table, what you can do is you can use that Q table to showcase or to call that, or this is basically predicting, or this is basically using the trend agent. Okay. So here I'm saying define showcase current position. Again, I'm initializing 0 0. Reach target false. While not in reach target, current position give me move is equal to np.argmax value table current position. So here always exploit. Here I'm not exploding because I'm predicting or I'm using the learned thing. Okay. Current position, reach target, time dot sleep. I'm simply saying you go ahead, this is your Q table, use it and reach 244. Okay. When you reach, let me know. So again, what I have to do, I have just defined all these functions. So basically I have to create an object of this class, which I'm doing now here. Training first and then the demonstration. And if I run this entire thing, right, you will see that training the agent, training complete. Starting demonstration, current position 0 0 initially, then it says 3, current position 0 1. So if you see here, right, what is position 3? Move right. Okay. So when the When the move is 3, then it will move right. So it will come to 0, 1, and so on and so forth. It will keep moving, and once it reaches 4, 4. So from 0, 0 to 4, 4, it has reached in these many iterations, these many, you can say, moves. And where from it has taken the reference? It has taken the reference from the Q table. How Q table got prepared? Q table got prepared in learning. How learning happened? First through exploration, then exploitation, and then Q table got enriched. What are the different parts of the code? Your agent, your environment, your Q table, your exploration, exploitation, your position, your movement, and then you can use that Q table and navigate through this. So this is basically how your reinforcement learning works. This is basically how the reward mechanism works. This is basically how the Q table, value updates, and things work. I hope you understood this concept. I will give you this notebook in my Git, and I will give you the link as well. Please don't hesitate to ask any questions that you have and practice and learn more on this aspect. See you all in the next video wherever you are. Stay safe and take care.